Good morning. My name is Antesh Chirag. Today I am going to teach the projectile motion. Right. So we have already studied in vectors as well as in motion in one dimension that we can write S is a displacement vector that Sx I cap plus Sy j cap plus Sz k cap. Similarly, for velocity is a vector as well as acceleration is a vector. Velocity vector we can write it in component form as Vx I cap plus Vy j cap plus Vz k cap, and acceleration as Ax I cap plus Ay j cap plus Az k cap. Right? Also, we have studied in motion in one dimension about three equations of motion. About three equations of motion. Equations of motion. That is, first one was V is equal to U plus AT. Second one was S displacement is equal to UT plus half of AT square. And the third one was V square is equal to U square plus 2A dot S. Right. So we can write each of these equations in its component form. Like we can write Vx, that is Ux plus Axt. Vy is equal to Uy plus Ayt, and Vz is equal to Uz plus Azt. Right, in component form all of these things, all of these equations are can be written. Right, similarly we can write the second equation as Sx is equal to Uxt plus half of Axt square. Right, similarly third equation Vx square is equal to Ux square plus 2Ax Sx. Right, so we are going to deal in two dimensions. In these two dimension I can take x-axis and y-axis, right, as well as we can take y-axis and z-axis and x-axis and z-axis, right. So in this particular case, for our simplicity purposes, we can take motion in two dimension, in xy plane, so the components that we deal with in xy plane is Sx and Sy, right. So similarly for velocity Vx and Vy, we are going to deal only in these two equations, right. So projectile motion, coming over the projectile motion that we are going to see is in x and y direction, right, projectile motion. So what are the examples that we can take of this projectile motion? Let's say a person, two friends are playing with a ball, and one friend one is throwing a ball, right, and second person is catching it. So we have seen that ball travels like the this frame, like, see, ball travels in this particular path, right. Similarly recently we have seen Neeraj Chopra throwing a javelin, right, that too travels in such a motion, and such motions are nothing but the projectile motion. The projectile motion. See, you throw a stone, right? You throw a stone to another person. In this case, that stone will travel in this particular path. That is, this path is particularly known as projectile motion. So we have to see that projectile motion. What we are seeing in the projectile motion is we are throwing a ball in a particular direction, and we are standing over a road. Let's say we are standing over a road, or we are standing in a over a ground, right? That is horizontal plane, horizontal plane, right. And the second plane was will be what? Vertical plane. This one plane is vertical plane, vertical plane, vertical plane, or you can say axis, vertical axis plane, or you can say vertical horizontal plane or horizontal axis. So overall we have to simplify, we have to see in simplified form, like we are throwing a ball, let's say we are throwing a ball or an object in a particular direction, right? Let's say this one is a ground, and from here a person is throwing a ball in a certain direction, right? We have seen the concept of direction, right, in vectors only. So initially I am giving this ball an initial velocity, that is u is what? Initial velocity. And the direction of this, since this is a velocity, this is a vector, right? So direction of we should specify some direction, right, of this velocity vector, that is I am taking it as u, that is a magnitude is what? Magnitude is what? U. Initial velocity v initial I can write v initial, the magnitude is nothing but I am taking it as u. So direction, what will be direction? Let's say with respect to this ground, or with respect to this horizontal ground, the direction of velocity is, let's say, alpha. So alpha is what? Alpha is the angle with respect to the ground or horizontal axis, right? So we have seen that what is the path taken by this projectile or a body, that is in such a way, right? In such a way. So we have to analyze. We have seen that what is a projectile motion, that is a ball is thrown, a ball, let's say an object is thrown with an initial velocity u, that is in the direction alpha with respect to what? Ground or horizontal axis. This is all about projectile motion. So we will see that what are the equations, what are the time period, time frame that it will return to the ground itself. What is the maximum height? We have to find what is the maximum height reached by this object, say. And the third thing is we have seen the time. I have to find out the time period, the maximum height, and what is the range. What is the range? So I have thrown a ball with an initial velocity at an angle alpha, right? So it will reach the ground at certain point. है ना? So this entire thing will be what range, है ना? And this maximum height, this height achieved is what? Maximum height. We'll see. We will analyze these. What is the h max? What is the range? As well as the time period of this flight. That is, let's say time period of the flight or projectile. So again, coming to the basics, we have seen that I can write acceleration as in component form ax I cap plus ay j cap plus az k cap. We can write velocity as vx I cap, vy j cap, vz k cap, as well as displacement sx I cap plus sy j cap plus sz k cap, right? And since we are dealing in only two dimension, that is I have taken it in xy plane, so I have to only consider what? Ax, x component as well as y component. There is no any need to deal in z component, right? So we can erase it. हम लोग इसको erase कर सकते हैं simplified form, right? So in this projectile, again, in this projectile, we have to see that what are the components of initial velocity, what are the components of final velocity in x-axis as well as in y-axis, that we are taking as vertical axis, right? So I am taking it as x-axis or horizontal axis. and I am taking the vertical, this axis, as y axis or vertical axis, and I am giving the projectile an initial velocity of u at an angle alpha with x-axis or horizontal axis. So here, what are the acceleration? Here, assumption. First of all, coming over the assumptions. First assumption is that only force that is applicable over the projectile is the gravitational force that acts that always acts towards the center of the earth. And where is the center of the earth? Just vertically downwards. We are standing here. The center of the earth will be what? Is exactly vertically downwards in our direction. So acceleration force is gravitational force is always in downward direction, or we can say always in downward direction. Right? Else every other force, else I'm repeating, every other force is negligible. We are taking it as negligible. Like other forces, example of other forces, every other force, every other force is negligible. Right? So what are the examples? Some of the examples of these forces that we take as negligible. That are those forces are, say, drag force due to air, drag force due to air, drag force or resistance force. See, whenever we travel, right? So whenever we travel, the air applies a resistance force in opposite direction, right? So in these cases, in all of these cases, we are taking that force, especially the drag due to the air, right, as negligible. So the only force that is applicable is gravitational force, and that is the direction of that force is always in the downward direction. Also, we know that the acceleration due to that force, the acceleration due to gravitational force is what? Force is what? In vertically downward direction, always. Right? So from this, if force is gravitational force, and we know, we have heard somewhere that force is equal to nothing but mass into acceleration. Right? So if the direction of the force here, gravitational force, I can write, I can add and substitute, that is Fg. So acceleration is only due to this force. So if the direction of this force is always in vertically downward direction, we will take the acceleration due to gravity here, due to gravitational force. Acceleration due to gravitational force is always in downward direction, vertically downward direction. So we have point 1 noted that gravitational force, only acceleration is due to gravitational force that always acts in vertically downward direction, right? So I have written it, signified it as vertically downward direction. Acceleration is vertically, and we have taken what? Acceleration vertical direction as y-axis. So I can take ay as g, that is in downward direction, right? So some of the basic concepts, like this one is x-axis, this one is y-axis. We are starting from where? Origin. We are starting from origin. Now, second thing is we take the upward direction as, let's say, upward direction as positive, downward direction as negative, forward direction as positive, and backward direction as negative, right? So if I am taking the downward direction as negative, so I can write the magnitude of ay is nothing but what? Minus of g, or say or say that vertically downward acceleration is magnitude of vertically downward acceleration is g. That is gravitational g is nothing but gravitational acceleration. And this is what? This is always constant, and the value of j is 9.8 meter per second square, or round off, it comes out to be 10 meter per second square, right? So this one is the case, right? So we have seen that acceleration in y-axis is always downwards, right? So what is the acceleration in x-axis here? The acceleration, since there is no any force in x-axis, towards x-axis, or towards negative x-axis, so here acceleration will be what? Always equal to, x is always equal to what? 0 meter per second square, right? So why? Due to, we have second assumption that force in x-axis is always taken as 0 for this particular cases, right? Further, when we go forward, means when we understand each and everything, then we can apply a force in x-axis, right? So due to that force, there will be an acceleration in x-axis also. But here initially we are taking x-axis, the force in x-axis is 0. So if this is the force is 0, then acceleration is also 0. X is always 0. And we have seen the case where acceleration is always 0. That is a case of uniform motion. That is a case of uniform motion. Uniform motion. Right? So we have seen the acceleration. Acceleration in x-axis is what? 0. Acceleration in y-axis is what? Always in downward direction. The magnitude of which is g. G का वैल्यू क्या होता है? That is 9.8 meter per second square, or after rounding off, that it comes out to be 10 meter per second square. Right? So let us proceed further. Now let us, after seeing the assumptions, after seeing the acceleration in horizontal direction as well as in vertical direction, we are going to analyze the projectile, right? So we are going to analyze the projectile. Here we have seen that the projectile motion is like this. Somewhere it comes on the x-axis again, right? Here the acceleration is in downward direction, right? Ay in downward direction, ax is always what? Equal to 0. So I can break initial, I have given the initial velocity of the projectile as u meter per second. In which direction? In the direction alpha with respect to horizontal axis, that is x-axis. Now we can break this, we can break the initial velocity in x direction as what? U cos alpha. That is nothing but ux, and u sin alpha, that is nothing but uy. Now, so I can write the components of initial velocity as ux, that is equal to u cos alpha, as well as uy, that is equal to u sin alpha, right? So acceleration is always downward direction, that is what? Minus of g. Now, so here I have seen that initial velocity is what? Vertically upward, u sin alpha. Acceleration is always downwards, g. So in this case, what is going to happen? What is going to happen? In this scenario, the acceleration, we have seen that the acceleration the acceleration when the acceleration is exactly opposite to our velocity, then the magnitude of then the velocity or magnitude of velocity will decrease, right? So in this case, velocity, initial velocity, we have given the initial velocity as uy, that is u sine theta, and acceleration is always towards negative x axis, negative y axis, sorry, negative y axis, downward, vertically downward direction, right? So in this scenario, in this case, velocity, our velocity is going to decrease in vertical component of, well, initial velocity is going to decrease, right? What about horizontal component of velocity? Horizontal component of velocity, this, since there is no any acceleration, no any acceleration in x direction, our initial velocity, the component of initial velocity in x axis is going to remain constant. That is nothing but ux, that is equal to what? U cos alpha. So we can see here in the projectile that your x component of velocity ux, u cos alpha, it remain what? Constant in entire projectile. And after traveling some distance, this initial component of x direction, velocity in x direction, that will remain what? U cos alpha. And what about y axis? Y axis, it will decrease, it will decrease, since acceleration is in exactly opposite direction, right? So this one is, let's say this one is vy, है ना, this one is vx, that is equal to ux only. Again, after traveling some distance, its velocity will again, vertical component of velocity will again decrease. V, let's say कि this point is 1, this point is 2, here v, I can write vy 2, and again ux will remain what? Constant, that is u cos alpha, है ना? So after how much time, or after reaching where, that there is a case where velocity, vertical component of the velocity, that is vy, is going to be 0. At some point it is going to be what? Equal to 0. Vy is what? Equal to 0. Only component that will remain is what? Ux, that is vx, that is equal to what? Ux, that is equal to u cos alpha. So after this point, what will happen? Let's say I have come over a point, this one is point 3, this one is point 4. So our initial velocity in x direction will remain what? Vx4, Vx4, that is u cos alpha. It will remain constant. What about vertical component of this velocity, final velocity? That will what? Change, that will change its direction. Since acceleration is always there, since there is an acceleration, always there is an acceleration in vertically downward direction. So after this point, after reaching a point, a certain point where vertical component become, or velocity becomes what? 0, it again starts increasing in what? In which direction? In downward direction. So I can write vy4. Now again, when we come over fifth point, right, here what will it will become? That one vx5, that is again u cos alpha, and velocity what? In y direction, that is vy5. So this is the whole scenario. This is the whole scenario. See, this particular case at point 3, if we focus over point 3, we can observe some speciality. What is the speciality here? That vertical component of velocity will become what? 0, equal to 0. So we have seen in motion in one dimension in vertical axis, and let's say for example एक बॉल को हम वर्टिकली अपवर्ड डायरेक्शन में इनिशियल वेलोसिटी से थ्रो करते हैं. क्या करते हैं? इनिशियल वेलोसिटी से एक बॉल को हम थ्रो करते हैं, यू से, राइट, ग्राउंड से थ्रो कर रहे हैं, राइट. यहां पर हमने देखा था कि एक्सीलरेशन ड्यू टू ग्रेविटी होगा ऑलवेज, दैट इज ऑलवेज इन डाउनवर्ड डायरेक्शन, राइट। वो इनिशियल वेलोसिटी क्या होगी, ये वेलोसिटी बाद में ये डिक्रीज होती है अप टू सर्टेन पॉइंट वेयर इट्स वेलोसिटी विल बिकम व्हाट, 0 मीटर पर सेकेंड, right? And after returning, then it will start to return in downward direction. यहाँ तक इनिशियल वेलोसिटी थी अपवर्ड डायरेक्शन में, यहाँ पर देखेंगे वापस डाउनवर्ड डायरेक्शन में आ गई, वापस कहाँ आएगी, वापस अपने इनिशियल पोजीशन पे आएगी, राइट। सो दिस हाइट दैट इट ट्रेवल्ड it was what, h maximum, that is the maximum height that the ball has traveled after giving an initial velocity of u in upward direction. We have studied it in motion in one dimension, right, in vertical axis, right, free fall, if you remember the free fall case, right. So we have seen from there that h maximum means displacement in vertical direction. Displacement in vertical direction, maximum displacement in vertical direction will be where, when its vertical component of initial velocity will become what, equal to 0. So here this one is what, your h max, right, maximum h max. So here we can write h max as the point in vertical direction or y axis, the point in vertical direction or in y axis where vertical component of velocity that is Vy will become equal to what, 0 meter per second, right. In that scenario we have seen that at h maximum we can observe that there is only an initial velocity in x axis, component of velocity in x axis, that is equal to initial component of velocity in x axis, right, that is nothing but u cos alpha, right. So this one is the condition. Now we come over what, time of flight. So what is the time of flight? What is the time of flight? We represent it as capital T. So what is according to you, what is the time of flight? That is nothing but the total time taken by this projectile in its entire path, right. So total time taken by the projectile to cover its entire path. So see, when I have thrown a projectile, एक बॉल को हमने थ्रो किया, राइट, सो वो कहाँ वापस रिटर्न होके ग्राउंड पे आएगा, हम ग्राउंड पे खड़े हैं, हमने एक बॉल को थ्रो किया प्रोजेक्टाइल के डायरेक्शन में, एक प्रोजेक्टाइल मोशन दिया उसको, तो बॉल वापस रिटर्न होके कहाँ आ गया, अगेन ग्राउंड पे आएगा, राइट. सो टोटल टाइम इट विल टेक टू कम अगेन ओवर व्हाट, एक्स एक्सिस और ओवर द ग्राउंड इज व्हाट, दैट इज द टाइम ऑफ फ्लाइट. सो यहां से स्टार्ट हुआ है और अगेन प्रोजेक्टाइल कहाँ है, वापस ग्राउंड पे आया है. तो द इंटायर टाइम टेकिंग टू ट्रेवल या टू कवर द इंटायर पाथ, दैट इज नथिंग बट टाइम ऑफ फ्लाइट. सो सी व्हाट, जो भी चीजें इस टाइम फ्रेम में हुई हैं, सारी चीजें क्या हुई हैं, इस विद इन दिस टाइम ऑफ फ्लाइट के फ्रेम में हुई है, राइट. लाइक वी हैव गॉन फ्रॉम इनिशियल पोजीशन to a vertical maximum, right, that is s maximum, and again we have come over the ground, right. So इस पूरे इंटायर जर्नी को हम ऑब्जर्व करेंगे. इस पूरे इंटायर जर्नी में क्या है, u cos अल्फा, हमारा u x मतलब हॉरिजॉन्टल डायरेक्शन, हॉरिजॉन्टल कंपोनेंट ऑफ इनिशियल वेलोसिटी विल रिमेन व्हाट, कांस्टेंट. तो इसी पूरे इंटायर टाइम फ्रेम में ये u cos अल्फा कांस्टेंट रहा है और ये इससे एक प्रोजेक्टाइल जो कवर कर रहा था ये हॉरिजॉन्टल डिस्टेंस या फिर हॉरिजॉन्टल डिस्प्लेसमेंट, दैट इज ड्यू टू दिस कंपोनेंट, दैट इज u cos अल्फा, राइट, इन दिस एंटायर टाइम फ्रेम. उसी टाइम फ्रेम में वो इनिशियल पोजीशन से एच मैक्सिमम में गया, फिर अगेन वापस वापस अपने एक्स कंपोनेंट पे एक्स हॉरिजॉन्टल प्लेन में वापस आया हुआ है, राइट. So that is time of flight, right. So we have seen that what is the h maximum, what is the time frame. Now the horizontal, then we come over the third thing, that is range. What is, we come over the range part. So let me erase this. We come over the range part. What is the range? Range, right, that is the displacement, the x component of a, या फिर the displacement from the initial position to the final position on what, horizontal axis or x axis in this case, right. So entire टाइम में एक पार्टिकल, एक प्रोजेक्टाइल इनिशियल पोजीशन ऑरिजिन से कहां चला गया, फाइनल पोजीशन तक चला गया. लेट अस टेल दिस एज पॉइंट बी, right. So entire from origin O to point B, this is entire is what, our range, right. So we'll see each and everything whatever I have described. I have described three things, that is time of flight, right, first thing. Second thing, maximum height, h max. The third thing is what, our range. Okay, so we will initially see the formulas, the derivation of the formulas of time of flight, that is capital T, maximum height, that is h max, and range, that is denoted by capital R, right. So in this video we'll try to cover the time of flight, the maximum height, as well as the range, okay, according to the time permits. Now we have seen that maximum height, the condition applied here was at h maximum, Vy was what, equal to 0. So in time of flight we have one condition, what, कि प्रोजेक्टाइल जो हमने इनिशियली ग्राउंड से फेंका था वो वापस कहाँ आ रहा है, ग्राउंड पे आ रहा है. सो वर्टिकल एक्सिस में, वाई एक्सिस में हमारा डिस्प्लेसमेंट क्या होगा, दैट विल बी इक्वल टू व्हाट, 0. जस्ट ऑब्जर्व हियर that initially it was on the ground, finally it was also on the ground, right. So displacement in y direction, what is the displacement in y direction, that is nothing but sy is equal to what, 0. We found out two conditions, right. We'll apply these conditions. Also there is a condition that initial velocity horizontal component of horizontal component of the velocity will always remain constant. Okay, now first thing we'll derive the time of flight condition. See, what is the time of flight? Right? Here we have seen, this is denoted by T. Here condition was Sy is equal to what? 0. Right? So Ay was what? That is equal to minus G. We have seen that vertical velocity is always in vertical acceleration is always in downward direction. that is what, minus of g, sy ay, right? So I have to find out what is the value of time, right? So here, since the acceleration is what, always constant, always in the same direction, and always magnitude of this acceleration is always 9.8 meter per second square, right? So acceleration is always constant, so we can apply the three equations of motion, that is s is equal to ut plus half of at square, v is equal to u plus at, and v square is equal to u square plus 2as. So in this case, we'll applying the second equation of motion, right? That is sy is equal to u by t plus half of a by t square, right? So applying this condition, putting this conditions, value of this condition, that is sy is equal to what, 0, ui is equal to what, ui, you have given that vertical component of ui, initial velocity, that is u sine alpha, right? So here I will write u sine alpha, and time is what, time is, let us take it as capital T, right? Plus half of ay is what, ay is minus g, and that is capital T square, right? So putting this, simplifying this equation, u sine alpha t minus of half of g capital T square, taking total time t as what, common from both, taking out total time t as common from both of these components, right? That it will become u sine alpha minus half of g t is equal to what, 0, right? Since we have seen that in a projectile, time period, time of flight will never be equal to what, 0. So in this case, only thing that can become 0 is what, this component. So equating this component u sine alpha minus half of gt, that is equal to what, 0. So from here we have got the time of flight, that is equal to u sine alpha divided by g. This is the total time of flight, that is 2u sine alpha divided by g. Or we can write, if we observe here that it is 2u sine alpha, right? And u sine alpha, we know that that is nothing but uy. So I can also write it as what, 2uy by g, you know, right? So this is the time of flight. This is the equation of time of flight. Now, can we have some examples here? So let's say, question is, let's say a projectile is given an initial velocity of 5 meter, or let's say 10 meter per second, right? At an angle, at an angle theta is equal to 30 degree with respect to horizontal plane. Then what is the time of flight, right? So time of flight will be what, we know that that is nothing but 2u sine alpha, what, by what, g, right? Here also take g as a value of 10 meter per second square, right? So putting the values, U is what? Horizontal component. Initial velocity is what? 10 meter per second. Right? So U is what? 10 meter per second. Sine alpha. Alpha is what? Alpha is what? That is 30. Sine 30 degree divided by what? G. G का वैल्यू हमने क्या लेना है? 10 लेना है. Right? That is equal to what? 2 into 10 into sine 30 degree, that is 1 by 2 divided by what? 10. Time का किस में आएगा? That will be equal to seconds. Right? So that is will come out to be 1 second. Okay? Now let us come over the maximum height part. Right? What will be the maximum height? So maximum height, that is H max. What were the conditions? Conditions were initial Uy was equal to what? U sin alpha. Right? Now Vy, final velocity condition of H max is what? 0 meter per second. Right? Acceleration is always, vertical acceleration is always minus g. Right? So can we find out what is the value of H maximum? So here also acceleration is what? Vertical acceleration is what? Always constant. So I can apply what? The equation of motion. So applying here, applying third equation of motion, equation of motion, that is Sy or Vy square is equal to Uy square plus 2Ay Sy. So here Sy is what? That is plus H max. Right? So Vy is what? 0. Putting these values in this equation, that comes out to be Vy is equal to 0 square is equal to Ui square or U sin alpha square plus 2 into what? Ay is what? Ay is nothing but minus g. And Sy is what? H max. Right? So simplifying this, U square sin square alpha minus 2g H max is equal to what? 0. So H max is what? H max is what? U square sin square alpha by 2g. Okay. Again here U square sin square alpha or U sin alpha ka whole square. U sin alpha the whole square, that is, so we have seen this term before, right? That is nothing but Uy. So this one is what? Uy square divided by 2g. So this is what? The formula of H maximum, that is U square sin square alpha by 2g, or we can say that Uy square by 2g. Both of these things are exactly same. Now again going over that question, that example was what? A projectile is given an initial velocity of U is equal to what? 10 meter per second. Right? And angle alpha was what? 30 degree with respect to horizontal. Right? G was taken as 10 meter per second square. So what will be the H maximum? H maximum in that case, H maximum was what? Is equal to U square. U square 10 square sin square alpha, sin 30 degree, sin square 30 degree, right? Divided by what? 2 into G ka value 10. That comes out to be 10 square, that is 100, sin square 30 degree, or that's the sin 30 degree will be equal to what? 1 by 2. Sin square 30 degree will be what? 1 by 2 ka square, and that is equal to 1 by 4 divided by 2 into 10, right? So cancel out, that is 5 by 4 meters or 1.25 meters. The maximum height will be what? 1.225 meters, right? So we have understood it from this section that what will be the h maximum in a projectile motion case, right? Now the third thing that left was what? The range. It was the range. So again, going back over the projectile motion, I projected a body with an initial velocity at an angle alpha with what? X-axis, horizontal plane or x-axis, right? This was what? Y-axis. You know, so it traveled like this, then again came back to or on horizontal plane or x-axis. So time taken was total time taken to come from A to B was what? That was nothing but time of flight. Time of flight or total time taken by projectile was what? Capital T, right? And we have seen that initial velocity, the horizontal component of initial velocity, that is u cos alpha, it will always remain constant, right? So uy or ux will always remain constant. So we have seen that displacement from initial position, this was what? Your final position, right? This was initial position. This was initial position, that was final position, B was final position. So the range will be what? We have seen here that on x-axis, on x-axis there will be uniform motion, right? Or uniform motion means ax acceleration will be equal to what? 0, right? So the total displacement. So we can find out what is the total displacement. Total displacement in x direction is equal to what? Initial velocity in x direction, velocity in x direction, or component of velocity in x direction into what? Total time taken, total time taken, right? Since this is a uniform motion in x axis or horizontal axis, we can apply this equation. That was what you have heard about, S is equal to V into T, right? For uniform motion case, motion case, right? So S is equal to what? Displacement. V is what? Velocity. T was what? Time, right? So we have seen that total time taken to cover this entire path is what? Time of flight, that was capital T. So displacement, can I write that displacement in x direction, this is nothing but what? Range. This was nothing but range, that is equal to Vx, V into x component of initial velocity into what? Total time taken, that is nothing but time of flight. That comes out to be what? Vx. We know what is the value of Vx, that is always equal to what? Ux. So u cos alpha. And we have seen the formula of what? Time of flight. Time of flight was what? 2u sine alpha by g, or 2uy by g, right? So here I can write 2u time, the formula of time flight, that is 2u sine alpha by g, right? So overall I can write 2u square sine alpha into cos alpha divided by g. right? So I can rebrand it like I can write it as u square 2 sine alpha cos alpha divided by g, right? So we know what is the net value of 2 sine alpha cos alpha, that is equal to sine 2 alpha. So u square sine 2 alpha by g. Okay, so this one is the case. The formula of what? Range, that is u square sine 2 alpha by g. Or I can also write it in this form. U cos alpha, I can write it as u what? Ux, right? Into what? 2u sine alpha or 2uy divided by g, right? So it comes out to be what? 2ux uy by. So range, the formula of range is equal to nothing but 2ux uy by g, or you can write it as u square sine 2 alpha by g, right? So we have derived all the formula of all three things, that is h, what is the formula of h max, what is the formula of time of flight, what is the formula of range, right? So in that case, let us again go back to the initial example. That was what? Initial velocity was given as 10 meter per second with an angle 30 degree with horizontal, right? So initial velocity was what? U is equal to 10 meter per second, and initial alpha was what? Alpha was 30 degree with respect to what? X axis, right? G, we have taken from the value of g as 10 meter per second square, right? So applying, putting these values in our range part, so range will come out to be what? U square or 10 square sine 2 alpha. Sine 2 alpha will be what? Sine 2 into 30 degree, right? Divided by what? 10 g, that is equal to 10, or 10 square, that is 100, into sine 60 degree. Sine, it comes out to be sine 60 degree, and value of sine 60 degree is what? Root 3 by 2 divided by what? 10. Here we can write, since sine 60 degree is equal to root 3 by, right? So again, simplifying this, we will get what? 10 cancel, 2 5 are 10, that is range will be equal to what? 5 root through root 3 meters. See, this is all from today's class. Rest we'll see in advanced class, what all the variations in the projectile motion, right? We'll see in further class. Thank you.